In this video, we will graph quadratic equations written in the form y equals ax squared plus bx plus c by first identifying key features of each parabola, including the x and y intercepts, the vertex, and the axis of symmetry. If additional points are needed in order to accurately graph the parabola, we will then choose some x-coordinates and calculate the corresponding y-coordinates from the equation. Our first example is y equals x squared minus 6x plus 8. Let's begin by finding the y-intercept. To do so, we just need to substitute x equals 0 into the equation, and we see the first two terms cancel out, and we have y equals 8. Therefore, the point 0, 8 is our y-intercept, and we can plot it on the coordinate plane. Now to find the x-intercepts, we let y equal 0 and solve the equation 0 equals x squared minus 6x plus 8. We can solve this by first factoring the trinomial as the product of two binomials, x minus 2 and x minus 4. Then applying the zero product property, we see that the two solutions are x equals 2 or x equals 4. This indicates that the parabola has two x-intercepts. One is at the point 2, 0, and one is at the point 4, 0. So we can plot those points on our coordinate plane as well. Now let's identify the axis of symmetry for this parabola. Remember that it's given by the formula x equals negative b over 2a. And in our equation, we have b equals negative 6 and a equals 1. So we have negative 6 over 2 times 1, which is simply 6 divided by 2, or 3. So let's sketch the vertical line x equals 3 as our axis of symmetry. And as expected, we see that it falls exactly midway between the two x-intercepts that we found earlier. Now, since the vertex lies on the axis of symmetry, we already know that its x-coordinate is 3. To find its y-coordinate, we can simply substitute 3 into the equation. So we have y equals 3 squared minus 6 times 3 plus 8, or 9 minus 18 plus 8. And since negative 9 plus 8 is negative 1, we see that the coordinates of the vertex are 3, negative 1. So let's plot that point on our graph as well. And to complete the graph, it would be nice to have one more point on the right-hand side of the parabola. And to obtain that point, we can observe that the y-intercept is exactly 3 units to the left of the axis of symmetry. So we can move 3 units to the right of the axis of symmetry and see that there is a point on the parabola at the location 6, 8 as well. Now we can draw our graph, and as we do so, we'll make note that, as expected, this parabola opens upward. We expect that because a was greater than 0, in this case a equals positive 1. Let's move to a second example, y equals negative x squared plus 5x. Once again, we can begin by identifying the y-intercept. In this case, if we let x equal 0, then we see that y also equals 0. So the point 0, 0, the origin, is the y-intercept of the parabola. To find the x-intercepts, set y equal to 0 and solve 0 equals negative x squared plus 5x. We'll factor with the distributive property and then identify the two solutions as x equals 0 or x equals 5. Now that first solution of x equals 0 corresponds to the origin, which we know is already the y-intercept, so it's also one of the x-intercepts as well. The second x-intercept is at the point 5, 0, so we'll plot that on the coordinate plane. Now let's find the formula for the axis of symmetry. X equals negative b over 2a. We have b equals 5 and a equals negative 1. So negative 5 over 2 times negative 1 would be 5 over 2, or 2 1/2. So let's sketch that vertical line. And once again, we see that it's midway between the two x-intercepts. The vertex must fall on that axis of symmetry, so we know its x-coordinate. Let's calculate its y-coordinate from the equation. We have y equals negative 5 over 2 squared plus 5 times 5 over 2, which is negative 25 over 4 plus 25 over 2. To add those two fractions, let's rewrite 25 over 2 as 50 over 4, so it has a common denominator. And then we see that the y-coordinate of the vertex is 25 over 4, which is a little bit over 6. So let's plot that. Vertex, 5 over 2, 25 over 4 on the coordinate plane. We can see that this parabola is going to open downward, and that's not a surprise because we see that a is less than 0, a is negative 1. But to get a better picture of the parabola, it would be helpful to have a couple more points. So let's just choose a value for x, such as x equals 1, and substitute it into the equation. So we have y equals negative 1 squared plus 5 times 1, which is negative 1 plus 5, or 4. So the point 1, 4 falls on the parabola, and by reflecting that point over the axis of symmetry, we would see the point 4, 4 also falls on the parabola. Now we have enough information to draw an accurate graph of this quadratic equation. Let's look at one final example, y equals 2x squared plus 4x minus 3. We'll begin again with the y-intercept. If x equals 0, the first two terms cancel out and we have y equals negative 3. So we'll plot the point 0, negative 3 on our coordinate plane. Now if we were to attempt to find the x-intercepts, we would have to solve the equation 0 equals 2x squared plus 4x minus 3. And that trinomial on the right-hand side is prime. And since it cannot be factored, we would have to solve this quadratic equation by another method, such as the quadratic formula. But this means that since we cannot solve by factoring, the x-intercepts are irrational numbers. So those will be difficult to identify and to accurately plot on the graph. So let's move on and identify some other points on the parabola instead. We can obtain the axis of symmetry, again using our formula, x equals negative b over 2a. In this case, b is 4 and a is 2. So negative 4 over 2 times 2 would be negative 4 over 4, which is simply negative 1. So we'll graph that line, x equals negative 1, as our axis of symmetry. The x-coordinate of the vertex is negative 1. To find the y-coordinate, we substitute into the equation. 2 times negative 1 squared plus 4 times negative 1 minus 3. So we have 2 plus negative 4 minus 3, which is negative 5. So our vertex is the point negative 1, negative 5. Now we can obtain a third point that's on the parabola simply by reflecting the y-intercept over the axis of symmetry to the point negative 2, negative 3. But it would still be helpful to have two more points to complete this graph accurately. So let's choose another value for x, such as x equals 1, and we can calculate the value of y from the equation. 2 times 1 squared plus 4 times 1 minus 3. This is 2 plus 4 minus 3, or 3. So the point 1, 3 is on the parabola, and we'll plot that on the coordinate plane. And then we will reflect it a distance of 2 units across the axis of symmetry to the point negative 3, 3. And then we'll use these points to complete the graph of this parabola, which once again is opening upward since the value of a is greater than 0.